let's take a look at rehashing. If our table gets too full, or so if our table's too full, it's going to result in a lot of collisions. If our table has too many tombstones, it will again result in us having to search linearly through the table or through some probing function. And these will cause the runtime of our hash table to suffer and to degrade. And so what we want to do in this particular case is we can build another hash table that's about twice as large, and we would have to associate it with a new hash function to ensure that that hash function would distribute the keys relatively uniformly over the entire size of the new table. We would then iterate through the original hash table, calculate the new hash value for each data item, each non-tombstone data item, and then we would insert that into the new table. There are a number of algorithms that try to do hashing more efficiently. Cuckoo hashing is one of them. It's actually covered in your textbook if you're interested in reading it. But I'll just give you a simple example of rehashing. So let's assume that we're using linear probing and we insert the following items in order. So you can verify that that the items are in the correct place. So that the size is 7, so 13 is the first item to go. 13 mod 7 gives me a remainder of 6. And 15 mod 7 gives me a remainder of 1, and 24 mod 7 gives me a remainder of 3. We then 6 mod 7 would actually be 6, but since slot 6 is already in use, we wrap around the table and you place the 6 in the 0 position. And at this point, we're going to say that through some user setting, we've decided that this table is too full and we want to be able to perform rehashing. So we will come up with a table size that is a prime number greater than 2m. And so the prime number that meets that in this particular case is 17. And we will take all of the items that are in the smaller hash table and rehash them into the larger table. So looking at the 6 mod 17 is 6, so that goes in location 6. 15 mod 17 is 15, it goes into location 15. 23 mod 17 is 6. You notice that we still can run into a collision, so we probe to location 7 and store 23 in that position. 24 mod 17 is 7, so we hash into this location. It's already occupied, and we probe and store 24 in slot 8. And finally, 13 mod 17 is 13 and allows us to store the data at that location. And so now we have more space, so there is less likelihood of collisions, even though because we used linear probing, we saw that there's some clumping taking place right around in this location. But nevertheless, there are bound to be, we've cleaned out all the tombstones because we don't transfer tombstones over to the new table. And this will lend itself to more efficient operation of the hash table. So that's pretty much a hashing in just a few videos. So we talked about a lot of different topics that are related to hashing. We talked about various hash functions. We talked about some methods for hashing, including separate chaining and including open addressing. We saw how to handle collisions in both of those methods, and we saw how to both search tables using either of those methods, to both search and to actually remove information. And we saw a manner of overcome some of the challenges that happen when we delete elements from hash tables that use open addressing. So that wraps up the hashing block.